In this lesson, we're going to be talking about the key attributes of graphs. By the end, you should be able to identify the key features of any graphical representation of a function, such as linear, exponential, and quadratic. And then you should be able to understand the key features transcend across different types of functions. The three basic models for our functions this year are going to be linear, quadratic, and exponential. Linear is a graph that gives you a line. Quadratic is a graph that gives you this U shape, or what we call a parabola. And then exponential is what we get is something that will give you an exponential curve. The x and the y intercepts. When we're talking about one of the key features, all of your graphs will ideally have an x and or a y-intercept. The x-intercept is where your graph crosses the x-axis, and it's going to be the ordered pair that has a y value of 0. So when x is touching when the graph is touching the x-axis, that y value will be equal to 0. The y-intercept is where your line crosses the y-axis, and reversely, the ordered pair will be 0, y, where x is equal to 0. So when your graph crosses the y-axis, that will be when x is equal to 0. Zeros, max, min, vertex, and axis of symmetry. These are key features that are not unique, but are typically found on quadratic graphs. Zeros are where your graph crosses the x-axis. So your zeros are going to be the same as your x-intercepts. The only difference is that when you're listing the x-intercepts, you write out the ordered pair. But when you're listing the zeros, you only list the x-coordinate. Your max and your min. So your maximum and your minimum value on a quadratic are going to be either at the bottom or at the top. It's where the graph turns. So that's where you're going to have your max or your min. If it's on the bottom, then obviously that's called a minimum. And if it is on the top, so if your parabola opened down, then this would then be your maximum. The vertex and the min and the max are going to be the same. Again, when you're listing your minimum and your maximum value, again, you're writing out that ordered pair, and when you're listing your vertex, you're writing out that ordered pair. So your minimum and your maximum and your vertex are going to be the same. Your axis of symmetry, this is the fold line. This is the line that makes your graph symmetrical, so it looks the same on both sides. Your axis of symmetry, your fold line, is going to be through your vertex, so it's going to be written as an equation because it's a line. So it's going to be your line of symmetry. All lines are represented as equations. So it'll be an x equals, and it's x equals wherever it passes through on the vertex. So if you look at the x-coordinate on your vertex, your axis of symmetry will be x equals and that number. We're talking about line of asymptote. Lines of asymptote are unique to exponential graphs. So you won't have a line of asymptote with with linear, and you won't have a line of asymptote with quadratic, but you will have a line of asymptote when we talk about exponential. Your line of asymptote for exponentials is also known as a horizontal asymptote. This is the line that goes under the lowest point of your exponential graph, and it's going to be written as a y equals. When we talk about exponential functions, and we'll talk about them a little bit later on in some later videos, but in an exponential function, your graph approaches a certain line. It's getting infinitely close to that line, but it's never actually going to cross or touch that line. And so we call that line of asymptote. So here, our line of asymptote would be 2. This graph is approaching 2 as far as the y-coordinates, but it will never fully reach 2. So our line of asymptote here would be y equals 2. Again, your line of asymptote and your axis of symmetry should be written as equations. Your axis of symmetry is an x equals equation. Your line of asymptote is a y equals equation. You should not just be stating numbers there. Okay, let's identify some of the key features on this graph. So we have a linear graph, and it wants us to identify the x-intercept, the y-intercept, and any potential zeros. So remember that your x-intercept is where the graph crosses the x-axis. So your x-intercept would be here. So this would be your x-intercept. And as a point, this would be, it looks like our graph is going by 2's, so this would be 6, 0. Again, we're listing out the ordered pair. For the y-intercept, this is where it crosses the y-axis. So this would be right here, this would be your y-intercept. And this appears to be going through 0, 3, or 0, negative 3. And then your zeros. Remember that your zeros are going to be located in the same place as your x-intercept, except we're not looking at the whole point, we're only looking at the x. So your zeros, or 0 here, would be 6. When we look at a quadratic graph, again, we have some things that are the same. So we're still looking for x-intercepts, y-intercepts. We're still going to be looking for the zeros. And then we were adding some new things in, such as vertex, axis symmetry, minimum, and maximum. So let's start with the x-intercepts. Remember that your x-intercepts are where it crosses the x-axis, so that would be these 2 points right here. So these would be your x-intercepts. So we've got 2 of them. Looks like this graph is going by 1s. So we have an x-intercept at 0, 0. And we also have an x-intercept at what looks like negative 4 is 0. We look at the y-intercepts. Again, we're looking to see where it crosses. In this particular case, our y-intercept matches our x-intercept. So our y-intercept in this case would be 0, 0. When we look at the vertex, so looking at the vertex is going to be, again, where your point curves. So this point right here, this is where it begins to curve. So this would be our vertex. So our vertex appears to be at negative 2 and 4. Now, if you recall, our vertex and our minimum and our maximum are the same. So it looks like here we have a max, and it's at that same point. So our maximum point is at negative 2, 4. And we want to circle that it's a maximum. That way we indicate that it's a max, that we know that it's a maximum and not a minimum. The same thing for your zeros. Remember that your zeros are going to be the same as your x-intercepts, except with your zeros, we only need to list out the numbers. So my zeros are negative 4 and 0. Make sure that you don't put those in parentheses, otherwise you've now written a point, and that would be incorrect. So our zeros are negative 4 and 0. What that leaves us with is with our axis of symmetry. So our axis of symmetry, remember, that is that line of symmetry that goes down the middle of our graph. So this would be that red dotted line that we have here. And it appears that our graph is going through negative 2. So our axis of symmetry would be going through the point negative 2. Now remember, axis of symmetry is going to be written as an equation. So that equation would be x equals negative 2. Okay, looking at an exponential graph, again, we want to be able to identify the x and the y-intercepts. So remember that our x-intercept is right here, and that would be at 0.5 and 0, or 1/2 and 0. Remember that our y-intercept is where it crosses the y-axis, so that would be this point right here. That would be at 0, negative 1. Remember that our line of asymptote, it's a line, so it should be written as an equation. We're looking at where does our graph approach, and what line, and it appears to be approaching the line of negative 4. So our line of asymptote would be y equals negative 4. Before watching the next video, I would like for you to consider the key attributes of an exponential function. As usual, please subscribe to this YouTube channel, and I look forward to seeing you in the next video.